This is section 11.6.2, not mutually exclusive or probability, and odds. Not mutually exclusive events and or probabilities. Since it is possible to get a diamond and a face card on the same card, the events of selecting a diamond or a face card are not mutually exclusive events. Let's review this again. If you have a standard 52 card deck and you are dealt a single card, the event of being dealt a diamond and a face card could happen. It could be a jack of diamonds, a queen of diamonds, or a king of diamonds. Since getting these events both to happen at the same time is possible, we call these two events not mutually exclusive. You'll remember from the last lesson that mutually exclusive events are ones that cannot happen at the same time. So we say not mutually exclusive events can happen simultaneously. And we have the following formula. If events A and B are not mutually exclusive, then the probability of A or B happening is calculated by taking the probability of A plus the probability of B minus that probability where they both occur at the same time, A and B. And the reason we have to subtract this piece off of the end is because the cases where both are happening at the same time will be included in the probability of A and in the probability of B. And we don't want to include these cases twice, so we have to subtract them once. You'll see this play out in the next example. You randomly select one card from a standard deck of 52. What is the probability of selecting a diamond or a face card? So we have the probability of selecting a diamond or a face card. Now remember that face cards are jack, queen, or king. So we start with the probability of selecting a diamond, and then we add the probability of selecting a face card, and then we're going to have to subtract the probability of selecting a diamond and a face card, or a diamond that is a face card. So let's go through and find these probabilities. The probability of selecting a diamond. There are 13 diamonds out of all 52 cards. The probability of selecting a face card. Jack, queen, king. There are 3 per suit. There are 4 suits. So there are 12 face cards in the entire deck of 52 cards. Then we have to subtract the diamond face cards. Jack of diamonds, queen of diamonds, king of diamonds. There are 3 of them out of all 52 cards. Now let me pause here and explain again why we're subtracting this piece off of the end. It's because our diamond face cards are diamonds, so they're included in there. Our jack of diamonds, queen of diamonds, king of diamonds is included in those 13 diamonds. And our jack of diamonds, queen of diamonds, and king of diamonds are included in those 12 face cards. So we don't want to count those 3 cards more than once. So what we have to do is we have to subtract them because we've already counted them twice. So we have to subtract them once. All right, now we have 3 fractions. They all have a common denominator. We can come up with our probability. 13 plus 12 is 25. 25 minus 3 is 22. We have 22 over 52, which reduces to 11 over 26. So the probability of selecting a diamond or a face card on one card is 11 over 26. All right, next we're going to talk about odds. Odds are another way to talk about probability. When stating odds in favor, you take the number of favorable outcomes to the number of unfavorable outcomes. We use this colon here to say the word to. So the number of favorable outcomes to the number of unfavorable outcomes. When stating odds against, we state the number of unfavorable outcomes to the number of the number of favorable outcomes. So let's take a look at some examples. You roll a single six-sided die. Find the odds in favor of rolling a 2. So we want odds in favor, so we're going to state the number of favorable outcomes, which there's only 1, 2 on a die, to the number of unfavorable outcomes. There are 5 other numbers on the die that are not a 2. So our odds are 1 to 2. Find the odds against rolling a 2. Well, since we want odds against, now we're going to state the number of unfavorable outcomes, which would be the 5 numbers on the die that are not a 2, to 1, because there's 1, 2 on the die. Here's another example. The winner of a raffle will receive a new SUV. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against your winning the car? Well, again, we are being asked to state the odds against us winning the car. So we're going to state the number of unfavorable outcomes. So if there were 500 raffle tickets sold and I bought 10 tickets, that means there's 490 tickets in which I will not win. So we take the number of unfavorable outcomes to the number of favorable outcomes. There are 10 ways in which I could win because I bought 10 tickets. Now, just like with probability, we always reduce odds. So 490 to 10 reduces to 49 to 1. Now, how do we go from talking about odds to talking about probability? If the odds in favor of event E are A to B, then the probability of the event happening is given by A over A plus B, where A is the number of favorable outcomes and B is the number of unfavorable outcomes. Now, this formula is the exact same formula we've used for probability up until this point. We've talked about probability of an event happening as the number of ways to get the event to happen over the total number of possible outcomes. So what we're calculating up here is exactly that. A is the number of favorable outcomes, or in other words, it's the number of ways to get the event to happen. B is the number of unfavorable outcomes, and if we add the number of favorable outcomes and the number of unfavorable outcomes together, we are coming up with the total number of outcomes. So going from odds to probability is really just understanding the probability formula that we've been using up until this point. Here's an example. The odds in favor of a particular horse winning a race are 2 to 5. So the odds in favor are 2 to 5. What is the probability that this horse will win the race? The probability of winning. The number of ways the horse can win is 2. And the total number of possible outcomes is 2 plus 5, which is 7. So the probability of the horse winning the race is 2/7. So that covers section 11.6.2, not mutually exclusive or probability, and odds.